Welcome to Honors Geometry 7.5, 7.6 Trigonometry. It's an introduction to trigonometry, elementary trigonometry if you wish, and we will definitely have some fun here. And of course the word trigonometry comes from the Greek three-angle measurement. It has to do with triangles and the measuring of them. So let's get right at it. The sine ratio. Alright, go ahead and write that down. Draw the picture, and then we'll talk about the sine ratio. So go ahead. Alright, now that you've got that written down, let's go ahead and talk about the sine ratio of acute angle A. The sine ratio is, looking at angle A right here, it's the opposite side over the hypotenuse. Looking at angle A, the opposite side is 3 and the hypotenuse is 5, so the sine ratio is 3 to 5. Looking at angle B, the opposite side is 4, and of course the hypotenuse is 5. So the sine ratio of angle B, and we as mathematicians don't want to have to write all this out, so we're just going to write SIN B, but it still stands for the sine ratio of acute angle B. That would be 4 over 5. Alright, let's look at another example. Looking at that, alright, go ahead and write it down, pause it, and then fill in sine of x and sine of y. And then when you come back, I'll have the answers down. So go ahead and pause it. I don't think you paused it. I said pause it. Really. To tell you the truth, I just forgot to write the answers down, so I had to repause it so I could write the answers down. Sine of x is 12 over 13. Sine of y, 5 over 13. So that is the sine ratio. Okay, the next ratio that we are going to talk about is cosine ratio. Here it comes. Alright, go ahead and copy the definition down as well as the triangle, and then we'll talk about what it means to be the adjacent side. Alright, go ahead and copy down. Alright, looking at angle K here, okay, 6 is obviously the opposite side, 10 is obviously the hypotenuse. Process elimination says that 8 has to be the adjacent. Okay, the adjacent side will always be a side of that angle. That right there is a side of the angle. Wow, that's really bad drawing. Sorry about that. Anyway, yes, that right there is the side of the angle. That's the adjacent side. So cosine ratio is the adjacent side over the hypotenuse. So the cosine of K is 8 over 10, which of course reduces down to 4 over 5. And the cosine ratio of angle L, the adjacent side is 6 and the hypotenuse is 10, so that would be 6 over 10, which of course reduces down to 3 over 5. That's the cosine ratio. The next ratio is the tangent ratio. Alright, go ahead and write that down, and go ahead and write the answers for tangent of K and the tangent ratio of angle L as well. After you get done writing those down, then restart this. So go ahead and pause. Alright, so tangent of K, 6 over 8 reduces down to 3 over 4, and the tangent of L, 8 over 6, which reduces down to 4 over 3. The cool thing about the two acute angles of a right triangle, the tangents of those two angles will always be reciprocals of each other. Of course, if you look at angle K, the opposite is 6 and the adjacent is 8. 6 over 8. That's where I got 3/4 from. Alright, let's move along. Got a couple more here for you. Okay, hey, have you noticed all the Pythagorean triples I've been using? Sure. Those really make it easier for giving examples for trig problems. Alright, sine of r. Remember that sine is opposite over hypotenuse. Okay, looking at angle r, opposite 15 over hypotenuse 17. 15 over 17. Cosine of angle r, adjacent over hypotenuse 8 over 17. And the tangent of r, opposite over adjacent 15 over 8. Looking at angle s, sine 8 over 17. Cosine 15 over 17. And the tangent of s, 8 over 15. Notice again that these two are reciprocals of each other. Hey, did you also notice that the cosine of one angle equals the sine of the other acute angle? It always works that way. And you'll talk about that more next year in trig class, how that actually happens. Alright. Moving right along. Oh my. This is just a great little memory device to help you remember which function, or sorry, which ratio is what sides. SOH-CAH-TOA. The sine is the opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. See, now you know what SOH-CAH-TOA is up on the board for. Now you know. Just a couple more examples and we'll be done. Remember our 30, 60, 90 triangle from 7.4? Well, here we go. What is the tangent of 60 degrees? Looking at this 60-degree angle, tangent of 60, opposite over adjacent, 10 root 3 over 10, reduce the tens, the tangent of 60 is root 3. How about the cosine of 60? That would be adjacent over hypotenuse, 10 over 20. That reduces down to 1/2. And how about the sine of 60? That would be opposite over hypotenuse, 10 root 3 over 20. Reduce the 10 over 20, and it would be root 3 over 2. Alright, that's just, boy, you guys will talk a whole lot more about these angles, and also 30-degree angles, and 45, 45, 90. Sorry, 45, 45. Alright, come on. I want to deselect that. There we go. Alright, so let's look at this 45-degree angle right here. Okay, what is the tangent of that 45-degree angle? Opposite over adjacent, 10 over 10. Wow. Tangent of a 45-degree angle? 1. Excuse me a minute, please. Wow, sorry about that. Dealing with a little bit of allergy problems this morning, I think. Alright, let's look at the sine of that 45-degree angle. Opposite over hypotenuse. 10 over 10 root 2. Cancel out the 10s. And you got 1 over root 2. Multiply top and bottom by root 2. And the sine of the 45 is root 2 over 2. How about the cosine of that 45 degree angle? Okay, the adjacent side is 10. The hypotenuse is 10 root 2. Hey, I just saw that. Cosine of 45 degrees is root 2 over 2. That's pretty cool. Alrighty then. Now let's put these trig ratios into practice. Okay, you got a 40 degree angle here. You're trying to figure out how big x is, and you got 4. So what you need to do is look at that 40 degree angle and determine what two sides are represented there. And I'm glad that you thought in your brain opposite and adjacent. Now ask yourself, what ratio deals with opposite and adjacent? That's right, tangent. So the tangent of that 40 degree angle equals x over 4. Cross multiply and we get 4 times the tangent of 40 degrees equals x. And then we can use a calculator to get that answer. Unfortunately, I don't have my calculator with me right now, so hold on a second. And my answer was 3.4. Make sure that your calculator is in degrees. I will show you how to do that in class, and we're going to always round to the nearest tenth unless told otherwise. Alright, let's play that game again. Okay, looking at the 40 degree angle. What side are the two that we have? X is opposite. 4 is hypotenuse. Which ratio deals with opposite and hypotenuse? Sine, that is right. Sine of 40 degrees equals x over 4. Cross multiply. 4 sine 40 equals x. So let me do that on a calculator quickly, please. 4 sine 40. That would be 2.6. So that missing leg is 2.6. Let's go ahead and do one more. Okay, looking at this one, you have looking at the 40 degree angle, you have 4, which is the adjacent side, and x is the hypotenuse. Which ratio deals with adjacent and hypotenuse? That's right, it's cosine. Cosine of 40 equals 4 over x. Cross multiply and you get x cosine of 40 equals 4. We want to solve for x. We're multiplying x by something, so our algebra skills tell us to divide by that to find out what x is. So divide both sides by cosine of 40. X equals 4 over cosine of 40. All right, let me figure that out. So x equals 5.2. And then the last picture. Looking at that x angle, okay, what side is this? This is the opposite. This is the adjacent. Which ratio deals with opposite and adjacent? Tangent. So tangent of x equals 5 over 4. You're going to have to remind me in class to finish this example. This does conclude Honors Geometry 7.5, 7.6.